Problem number 10. Y equals negative cosecant of pi over 4x plus 1. We want to graph this, and the first thing that I see in this equation is there's a negative out in front of it. And a negative out in front of it means that we're going to reflect over the x-axis. The second thing that I see is that we have plus 1 at the end, which means that we have a vertical displacement of up 1. And I don't know why I started in that order, but I should have just gone in order, but the period. Well, eventually what we're going to be doing is we're going to be graphing this function y equals negative sine of pi over 4x plus 1. And we need to come up with the period of this. And the period of sine is 2 pi, which means that the period of cosecant is also 2 pi. So to calculate our actual period of this function, we're going to take 2 pi divided by pi over 4, which really means 2 pi times 4 over pi. When dividing donuts by, I flip the second one to multiply. Well, that gives us 8 pi. 2 pi times 4 over 1 times pi. And 8 pi divided by pi is just 8. So we get over here 1, 2, 3, 4. We get an 8 for our period. In fact, I'm going to put the 4 in here as well. And that may or may not help us when it comes to the asymptotes that we're going to be drawing when we draw this particular function. With respect to the domain, it's going to be for all reals such that x doesn't equal something times n, where n is, and then we're going to fill that in. And we'll look at our range momentarily. But once again, what we're going to do is we're going to draw our sine function, and as I get my highlighter over here to put this value in, I'm going to put the up one. And we don't have a phase shift, so we're going to leave it here. And hopefully you can draw a straighter line than not. But as we take a look at this now, again, we're going to draw our sine curve. And remember that sine starts at 0. So we start at 0, we end at 0, and our middle point is 0. And normally what we would do is we would go up a distance of 1 and then down a distance of 1, but we're reflecting the graph over the x-axis. So we're going to go down 1 and up 1 here. But don't connect the dots there, because what we've got on our yellow line there is we have where the zeros of the function are. And that means that we have an asymptote here. And if we hadn't moved that yellow line up, that would actually be on the x-axis, the 0 on the x-axis, and that's where, when we would take the reciprocal, we would get an undefined value. So we're able to get in those asymptotes right there, and once you get them in, then we can just continue the pattern. But we're able to draw our function as well. The first point here is underneath the yellow line, so we're going to draw it going downward. Our second red point is above it, so we're going to draw it above, and then we can simply copy our pattern. Oh, not there, here. And then we're going to go here. And we could keep drawing, but there's definitely 2 periods, and you can keep drawing again with respect to the pattern. So we can put those values in. watch the directions because it says to grab at least 2 periods. And now that we've got that, I'm going to relabel a little bit. And what we have down here is that our first positive asymptote's at 4. So I'm going to be filling in 4 there. And then our next asymptote's here at 8, which would make the next one at 12, and the following asymptote at 16. And what our n is, this would be 4 times 1. And then 8 is 4 times 2. And then it's 4 times 3 gives us 12. And 4 times 4 gives us 16. So we're looking at those red values, the 1, the 2, the 3, the 4, and what we see is that n is simply going to be an integer. Lastly, what we want to look at here is what is the range of this function, and what the range of this function is it's going to be negative infinity up to 0, parentheses, and then union, which is joined with, and then our low point in our upper branch there is at 2 to infinity.